Go.
Hello, my name is Victoria, and today I'll be going over how to assign point groups. So with point group, there's three things that you want to look at. So the first one being the axis of rotation. If the item only has one axis of rotation, we will mark it down as a C. But if there is a C2 perpendicular to a primary axis of rotation, we'll mark it as a D. So let's just take this bottle of tea, for example, going down straight this way. You could see that if I rotate this 90 degrees, it will look the same. And if we rotate it 180 degrees, it will also look the same. So it does have a primary axis of rotation. But however, if I flip it this way and try to look for a C2 perpendicular to that, there would not be any perpendicular rotation, as these two ends will be very different. So this will be marked as a C. Next up is the highest order of axis rotation. As I stated before, this bottle, you could rotate it 180 or 90 degrees to get that symmetry. So with 180 equals to 2 and 90 equals to 4, 4 being the highest, this will be a C4. Next up is mirror plane. So since we do not have a perpendicular axis of rotation, we could eliminate sigma h. So if we are to cut this bottle down, straight down like this, or at the corner, we would get symmetry. So when we only have a C, we will use sigma V, but if we have a D, it will be sigma D. So for this one, it will be C4V. And here are some special cases that we want to take note of. All right, now that we have learned how to assign some point group, here at Tabler we have my partner Mike, and he will help us assign some point groups today.
All right. Hi, my name is Mike. So as we can see, I don't see any axes of rotation. I don't see any mirror planes, and I don't see any point of inversion. But it does have an identity, and that identity is E. So therefore, this structure has a point group of C1.
Okay, Michael, now that we're at Roosevelt, assuming that this bell does not have any cracks or missing pieces, assign me the point groups.
Okay, awesome. So basically there is an axis of rotation, and that's C infinity. There is no perpendicular axis of rotation, however. We also do have a mirror plane if we cut along the poles this way and that way, and that is sigma V. Therefore, the point group is C infinity V for this bell.
All right, so this is our last stop, the embellic torus. Michael, assign me the point group.
Okay, got it. So after walking around the structure for a little bit, I know there's a axis of rotation. It's C2, it's going up and down. I don't think there's a perpendicular axis of rotation, and I don't see a mirror plane, so I'm pretty sure that the point group is C2. All right, and that's all for our tour today. Make sure to join us next time.